Assalamualaikum warahmatullahi taala wabarakatuh. Okay, this is part 3 video for chapter 6, data design. As promises, in this video, we will cover data relationship and a few other objectives, such as normalization, database models, data storage, and data control. Okay, in a data relationship, you have learned about ERD, right? Entity relationship diagram, which is a model that shows the logical relationships and interaction among system entities, which provides an overall overview of the systems and a blueprint for creating a physical data structure. What is entity? Okay, entity can be a person, place, things, or even for which data is collected and maintained. Okay, for example, entities might be customers, products, or orders. Okay, and information systems must recognize the relationships amongst entities. For example, a customer entity can have several order entity, and employee entity can have one or non-spouse entity, right? Usually, entity relationship diagrams involves three types of relationships, which is one-to-one, one-to-many relationship, many-to-many relationships, and cardinality describe numeric relationship between two entities and learn on how to model the interaction by adding cardinality notation, cross and put notation, and unified modeling language. Okay. Okay, these are the examples of cardinality notation using crossfold. Okay, there are 4 examples show how you can use various symbols to describe the relationships between entities. Okay, the first one is cardinality notation of one and only one customer can place anywhere from zero to many of the other entity. And the second one example is one and only one order can include one item ordered or many. Okay, the third one, one and only one employee can have one spouse or none. And the last one is one employee or many employees or none can be assigned to one project or many projects or none. Okay, you can watch ERD videos attached for better understanding. Okay, basically at this stage you should already understand database elements and their relationships, right? And you can now start designing tables for your project. So the first step in table design is doing a normalization. Okay, what is normalization? Normalization is the process of creating table designs by assigning specific fields or attributes to each table in the database. A table design specifies the fields and identifies the primary key in a particular table or file. So basically, normalization used to develop an overall database design that is simple, flexible, and free of data redundancy. And involves applying a set of rules that can help you identify and correct inherent problems and complexity in your table design. Okay, so the normalization process typically involves 4 stages, which are unnormalized design, first normal form, second normal form, and third normal form. Okay, the 3 normal form constitute a progression in which third normal form represent the best design. Okay, so most business related databases must be designed in third normal form, right? So later we will zoom in one by one of those stages, right? Okay, standard notation format of normalization. Okay, in designing table, it is easier if you use a standard notation format to show a table structure, fields, and primary key. Okay, this is the example of standard notation format, which is start with the name of table. Okay, followed by a bracket that contains a field name separated by comma. Okay, and the primary key is underlined. Okay, this is the standard notation format for designing tables, right? Okay, during data design, you must be able to recognize a repeating group of fields and unnormalized designs. Okay, a repeating group is a set of one or more fields that can occur any number of times in a single record, with each occurrence having a different values. Okay, repeating groups often occur in manual documents prepared by user. Right. Okay, this is example show repeating group. Okay, the first to record in the order tables contains multiple products, right, which represent a repeating group of fields. So a table design that contains a repeating group is called unnormalized design. Okay. Okay, now we start on how to normalize the table design. Um, we have three stages, as I mentioned in the previous slide, which are uh, first a normal form, second normal form, and third normal form, right? So here we start with the first normal form. Okay, a table is in first normal form if it does not contain a repeating group. So to convert an unnormalized design to a first normal form, you must expand the table's primary key to include the primary key of a repeating group. Okay, look at this example. Okay, it has a combination of a primary key, right? So the primary key of the first normal form design cannot be the order number field alone, because the order number does not uniquely identify each product in a multiple item order. Okay, in other words, product number cannot be the primary key because it appears more than one if several orders include the same product. Okay, and therefore the primary key is the combination of two fields, which is order number and product number. That's the first normal form. Okay, next is the second normal form. Okay, basically to understand a second normal form, you must understand the concept of functional dependence. Okay, for example, uh, field X is functionally dependent on field Y if the value of field X depends on field Y. Okay, look at this example, order date value. Okay, uh, is functionally dependent on the order number because for a specific order number there can be only one date. Okay, okay, this example. And in contrast, a product description, okay, is not dependent on the order number, right? So for a particular order number, there might be several product descriptions, which is one for each item order. Okay. You have to see this example. Okay, that's the second normal form. Okay, converting table from first normal form to second normal form. Okay, the objective of converting a table from first normal form to second normal form is to break the original table into two or more new tables and reassign the fields so that each non-key field will depend on the entire primary key in its table. Okay, so a standard process exists for converting a table from first normal form to second normal form, which is number 1, is create and name a separate table for each field in the existing primary key. For example, order number with the order number primary key and product with the product number as primary key. Okay, the second one is to create a new table for each possible combination of the original primary key fields. Okay, example here, order line with the primary key, order number, and product number. And the third one is study the 3 tables and place each field with its appropriate primary key. You can refer this example to the figure in the previous slides, and you can see, you can better see in the tables, right? So I think that's all about the process for converting table from first normal form to second normal form. You can watch a tutorial videos attached for better understanding, okay? Okay, this figure shows the second normal form table designs. Okay, by following the steps, the previous step that I have explained in the previous slide, you have converted the original first normal form table into 3 second normal form table. Okay, why is it important to move from first normal form to second normal form? Okay, there are 4 kinds of problems are found with first normal form description that do not exist with second normal form. Number 1 is consider the work necessary to change a particular product's description. Okay, because changing the product description involves modifying a lot of records and it would be expensive. Okay, the second one is first normal form tables can contain inconsistent data because someone must enter the product description in each record. Nothing prevents product from having different product description in different records. Okay. The third one, adding a new product is a problem because the primary key must include an order number and a product number. So you need values for both fields in order to add record. And the fourth one is deleting a product is a problem. Okay, for example, if all the related records are deleted once and order is filled and paid for, what happens if you delete the only record that contains a certain product number? Okay, the information of that product number and its description will be lost. Okay, now is a popular table design which is third normal form. Okay, as you can see, a third normal form design avoids redundancy and data integrity problems that still can exist in a second normal form design. Okay, a table design in third normal form, if it is in second normal form and if no non-key field is dependent on another non-key field. Okay, for example, in this figure, you can see the customer example in this figure is not in third normal form because one non-key field, sales representative name, depends on another non-key field which is sale representative number. So in the customer example in this figure, the sales rep name field depends on another field, sale represent number, which is not part of the primary key. Therefore, to reach a third normal form, you must remove sale representative name and place it into a new tables that use sale rep number as a primary key. Okay, this is how you can convert second normal form to third normal form. Okay, after normalizing your table designs, you are now ready to create a physical database. Okay, These are the steps that will help you construct a database that is user-friendly, efficient, maintainable, and meets IT industry design standard. Okay. Number one, you have to create the initial ERD, which is at this stage, you start reviewing your data flow diagrams and class diagrams. You identify all system entities and carefully analyze each relationship to determine if it is one-to-one, one-to-many, or many-to-many relationship. Okay. Uh, the second step is assign all data elements to entities, meaning that you have to create a data dictionary. Okay. The third one is to create a third normal form designs for all tables, which is you have to take care to identify all primary, secondary, and foreign key. And the last step is to verify all data dictionary entries. Okay, which is after creating your final ERD and normalized table design, you can transform them into a database. Hierarchical and network database. Okay, in a hierarchical database, data is organized like a family tree or organization chart with branches representing parent records and child record, right? And a network database resembles a hierarchical design but provides somewhat more flexibility. Relational databases is a model introduced during the 1970s and became popular because it was flexible and powerful. Okay, because all the tables are linked, a user can request a data that meets a specific condition. So new entities and attributes can be added at any time without restructuring the entire database. Okay. Okay, object-oriented databases. Many systems developers are using object-oriented database design as a natural extension of object-oriented analysis process, which consists of object data standard, object database management group, and each object has a unique object identifier. Okay, this is the example of object-oriented database. Okay, now we move to data storage. Okay, data storage and access involve strategic business tools such as data warehousing and data mining software, as well as logical and physical storage issues, selection of data storage format, and special considerations regarding storage of date fields. Okay, usually, companies use data warehousing and data mining as strategic tools to help manage the huge quantities of data that they need for business operation and decision. Okay, we start with data warehousing. Okay, for large firms, they are maintaining many databases, right? So to provide a rapid access to this information, companies use software packages that organize and store data in special configurations called data warehouse. Okay, data warehouse allows user to specify certain dimension of or characteristic. Okay, so without data warehouse, it would be difficult for a user to extract data that spans several information systems in time frames. And it allows user to retrieve and analyze the data easily, right? Okay, data mining. Data mining is a software looks for meaningful data patterns and relationships. For example, data mining software could help a customer products firm identify potential customers based on their prior purchases. Okay. Data mining work best when you have clear measurable goals. For example, increase average pages viewed per session, increase number of referred customers, reduce click to close, increase checkouts per visit, and increase average profit per checkout. Okay, logical and physical storage. Uh, Basically, it is important to understand the differences between logical storage and physical storage, right? Okay, logical storage refers to data that a user can view, understand, and access regardless of how or where that information actually is organized or stored. Okay, um, which is in contrast, physical storage is strictly hardware related because it involves the process of reading and writing binary data to physical media such as hard drives, CD-ROM, or network-based storage device. Okay, so logical storage, as seen through users' eyes, characters, date elements or data item, and logical record. Okay, example of physical storage, hardware related, okay, physical record or block and block vectors. Okay, these are the example of data storage formats. Okay, binary digits, bit, byte, ABCD and ASCIIs. Okay, ABCD basically stand for Extended Binary Coded Decimal Interchange Code. It is a coding method used for mainframe computers and high capacity servers. Okay, ASCII is a stand for American Standard Code for Information Interchange. It is a coding method used on most personal computers. Uh, okay, these two storage format require 8 bits or 1 byte for each character. Okay, okay. Unicode is a more recent coding standard that use 2 bytes per character rather than 1. Okay, okay. Binary format. Uh, Actually, compared with character-based formats, a binary storage format offers a more efficient storage method because it represents numbers as actually binary values, okay, rather than as coded numeric digits. Okay, example of a binary format is integer format, long integer format, and other binary formats that exist for efficient storage of exceedingly long numbers. Okay. Okay, selecting a data storage format. In many cases, a user can select a specific data storage format. Okay, for example, when using Microsoft Office, you can store documents, spreadsheet, and databases in unique compatible form by using a font called Arial Unicode MS. Okay, selecting a right data storage format depends on the situation, right? Okay, for date fields, most date formats now are based on the model established by the International Organization for Standardization, ISO. It can be sorted easily and used in comparisons and absolute date. The best method for storing date fields depends on how the specific date will be printed, displayed, or used in a calculation. Okay, data control. Okay, just important as how you secure the physical part of the system, right? File and database control must include all measures necessary to ensure that data storage is correct, complete, and secure, right? A file and database control also is related to input and output techniques discussed earlier. Okay, a well design DBMS must provide a built-in control and security features, including subschemas, passwords, encryptions, audit trail files, and backup and recovery procedure to maintain data. Okay, these are the example of data control, which is user use proper user ID and password to access a file or database. All system file in databases must be backed up regularly. Um, Recovery procedures can be used to restore the file or database to its current state at the time of the last backup. Okay. Audit log files, which record details of all accesses and changes to the file or database can be used to recover changes made since the last backup. You also can include audit fields, which are special fields within data records to provide additional control or security information. And the last one is encryption. Okay, stored data also can be encrypted to prevent unauthorized access. Okay, encryption is a process of converting readable data into unreadable characters to prevent unauthorized access to data. Okay, with that, I think that's all for chapter 6. Okay, see you in the chapter 7 video. Assalamualaikum warahmatullahi wabarakatuh, and thank you.